So in this video, we'll look at how to find the full equation of a line given two coordinates. So before we do that, let's just talk about the general form of a line first. Y equals mx plus c. So in case you don't know already, m in this stands for the gradient, and the gradient is defined as the change in y over the change in x. And if we look at the graph on the right, what we can do is pick two corner points. So I will pick this point here and this point here. Okay, if we want to find the change in y, we look at how much it goes up by between those 2 points, and it goes up by 1, 2, so the change in y is 2. And for the change in x, how much does it go across by? It goes across by 1, so 2 over 1, so the gradient of this line is 2. So that means for every 1 it goes across, it goes up by 2. Okay, and c, what does c mean? C here is essentially just the y-intercept. The y-intercept, and that talks about where it crosses the y-axis. So on this graph on the right, as you can see, it crosses at 3, so the y-intercept will be 3 for this line. And now we know m and we know c, we can write the full equation of the line. Y equals not mx but 2x, and not c but 3. So y equals 2x plus 3. Alright, let's look at a question now. So we're given two coordinates, 2, 5 and 6, 13, and we need to use those coordinates to find the full equation of the line. So we need to know m, the gradient, and c, the y-intercept. What we're going to start with is m. We'll find the gradient first. So gradient is change in y over change in x. And what we need to do there is take the second y coordinate and subtract for the first y coordinate over the second x coordinate minus the first x coordinate. So the second y coordinate here will be 13, because that's the y coordinate of the second point, and the first y coordinate is 5, over the second x coordinate, which is 6, minus the first x coordinate, which is 2, so you get 8 over 4, which is 2. So the gradient of this line is 2. Now to find the y-intercept, you take one coordinate and you combine it with knowing the gradient of 2, and you'll essentially get the y-intercept from there. So I'm going to pick the point 6, 13, but I could have picked the point 2, 5 as well. So y equals mx plus c, but we know m is 2, so we can write y equals 2x plus c, and all I'm going to do is substitute in the values for y and x for this coordinate of 6, 13. So the y coordinate is 13, so 13 equals 2 lots of, and I'll fill in the x coordinate, which is 6, plus c. 13 equals 12 plus c, and therefore c equals 1. So now we know m and we know c, and we can write the full equation. Y equals 2x plus 1. Okay, so what we did there is first find the m, the gradient, and we use that to then find the c, and we've got our full equation. Okay. A bit of a trickier one now. Do the same thing. So we'll do the second y coordinate, which is minus 2, minus the first y coordinate, which is 4, all over the second x coordinate, which is 5, minus the first x coordinate, which is 3. So that's the change in y over change in x. Minus 2 minus 4 is minus 6, and 5 minus 3 is 2. And this comes to a gradient of minus 3. So m is equal to minus 3. And then we use one of the coordinates and combine it with the gradient and find the y-intercept. So I'll pick the point 3, 4. So I'm not going to write y now. I'm going to substitute the value of 4 in there, because that's the y coordinate of that first point. So 4 equals not m, but minus 3, because we know the gradient is minus 3. And not x, but 3, because the x coordinate on that point is 3. And plus c. So 4 equals 3 times by 3 minus 9, plus c. Rearrange, and c equals 13. So we know m, we know c, and therefore the full equation is y equals minus 3x plus 13. So that's your final answer.